Well, g'day, and thanks for joining me again, due to popular demand. um, I've decided that I will explain the moon phases on the flat Earth, because I do get asked this quite a lot, and you see a lot of jokers come up in the comments saying that I can't even explain moon phases on the flat Earth. So, first and foremost, I think it's imperative that we understand the moon model as we observe it. Now, this is something I believe that I'm quite unique in describing, in that I don't think anybody else has described it this way. I often get a lot of flack for people sound biting me saying, oh, the giants created the moon and filled it with helium and put it up there. Now, in a nutshell, perhaps that's actually got an iota of truth to it, but I do believe that the raw materials for the moon were mined here on Earth, and the best evidence for such a mine would be something like the Grand Canyon. I didn't say it is the Grand Canyon, but it seems to be a likely sort of place to mine the raw materials to smelt them. And if you look at a lot of the ancient maps, in fact, you'll find that California has always been charted as a separate island, almost continent, well, not quite big enough to be a continent, but it's a separate landmass altogether. It's an island, and this fits with the theory that I'm toying with. You know, this is an incomplete theory, but basically I would think that to smelt the raw materials you would need a massive furnace, and what better furnace than something like Yellowstone National Park, deep underground, something volcanic, hot, large, big enough to smelt the raw materials. It's a theory. I'm working on it. And I believe then that all that landmass between California and the mainland of the USA is basically dead lands. It's waste, deserted. It has a salt-on sea. It's exactly what you'd expect if you're getting huge amounts of industrial waste as you're extracting the materials you're looking for and have to dump somewhere and cool rapidly. Well, that could explain the land bridge between California and the USA as we know it today. So I'll just leave that there where it is. I believe the moon was smelted. I believe it was inflated like a giant bauble, blown up like a balloon type of thing, and that all the craters we see on it, and this is how I developed my theory in the first place, that the craters are the result of bubbles bursting on the surface and setting into place rapidly as it rose up towards the firmament and cooled very rapidly. So a lot of the bubbles eventually set in place, leaving behind what we see as craters. In fact, you can even see a little dollop in the center of a lot of these perfectly round craters. And pretty much the only thing in nature that creates perfectly round things is bubbles. So the moon itself is a bubble or a bauble, and the bubbles on the surface are perfectly round. I'll leave that there. It's just the phases that we're concerning ourselves with here today. And so the magic whiteboard may or may not even be needed. Basically, there's two things to consider with there's multiple things to consider. I think I explained in the last long rant that I made with the whiteboard about how sunlight works, how we require, we've got the Earth, which is, you know, the lumpy bumpy bit across the bottom with flat level water. Oh, that's really flat and level. In between all the lumpy bits, and there are oceans. And then we've got the sky level, and then we've got the firmament, which is like a dome over the top. And so that the sun, wherever it may be, shines through the firmament. So a person down here is going to see it in the firmament here, and a person down here is going to see it here, etc., etc. But this atmosphere here, the firmament B, that's a gaseous layer. And it's this gaseous layer where this light, because all here is darkness and all here is the blue sky of daylight. And of course it doesn't shine over the entire Earth. Half the Earth is going to be in darkness. And the moon, as I believe, is on the inside of the firmament, so it's this tiny little dot. It takes the sunlight that hits upon it and projects it down towards the viewer, and it renders the visible moon to us. So that visible moon is the holographic projection. So we've got noble gases here. Now a lot of people will tell you, oh, noble gases, you know, like even argon is only about 0.9% of the gases constituting the atmosphere, and that's exactly right. And things like krypton, xenon, neon, and there's another one as well, they're even less than the 0.9%. However, if you were offered by somebody who had a very large amount of money, let's say he has $100 billion trillion, that's a lot of dollars, and he says, I like you, I'm going to give you 0.001% of my money, would you turn around and say, oh, bugger off, you greedy old bastard, I'm not taking that? If you accepted his offer, you'd be the richest person on earth. You would have more than you knew what to do with. So when we say that the noble gases constitute less than 1% of the atmospheric gases, there's a lot of atmospheric gases, so therefore there's a lot of noble gases, and that's why they're subtle. That's why daylight doesn't just go bam and blind you like looking at the sun. It is only 0.9% of the noble gases in the sky, and I'm not even sure what the actual percentage of krypton in the sky actually is. However, that tiny amount is sufficient that the sun energy projected into the moon and reflected down into firmament B stimulates, completely separate from all the other gases, it stimulates krypton. And krypton is a noble gas that glows basically black and white. It doesn't have colour. That is why if you go out under a full moon, you can actually read a book under the full moon light, but if you found there was coloured images on the page, you wouldn't see the colour. They would appear as black and white images. So moonlight is a black and white light, for want of a better term to explain it. And so basically, you're still seeing a personal projection. So this person over here is going to see their projection here, this person over here is going to see their projection there, and so on and so forth. So we're all seeing a different projection of the moon in a different part of the firmament B, or our atmosphere, at the same time. And the reason we see the exact same phase of the moon is because the sunlit part is still lighting the exact same part. So the holographic projection of it is going to appear identical. The only thing that will change is if you're on a different side of the equator looking up at it. It'll be exactly like if you put a picture of anything on the ceiling. Say you drew a smiley face on the ceiling and you walked to one side of the room and looked at it, you see a smiley face. You cross the room, you look at it, now you're seeing it upside down, a frowny face. That's all you're seeing, is why the moon appears inverted to people on different sides of the equator. We're not in a different hemisphere, we're on a different side of the equator. So if you can understand, basically, I didn't bring a 2 seconds. Okay, that was actually 3 seconds. So if we're looking down upon the Earth from above, and we decided the Earth was a circle, and we've got the equator in the middle, we've got the North Pole there in the centre, like a big dartboard. So the sun goes around the equator 24 hours. The moon, on the other hand, let's see, so that's the moon. When the moon is over here, that's a full moon. When the moon is over here, it's a half moon, so it's also a half moon here. So the lit side, that's a terrible moon. Bad moon, get gooder. The lit side is always going to be facing the sun. So we've got the tiny crescent moon here, tiny crescent moon there. The new moon, when the moon is here, sometimes eclipsing the sun, the moon is invisible because it's only the lit side of the moon that gets projected down, as I said, into the firmament B to show us the different phases of the moon, etc., as it projects throughout the month. So the sun takes 24 hours to go around once every day. The moon takes 24 hours and 50 minutes. So on the day of the new moon, it's pretty well tracking the sun all the way around, but it lags then back to here. So at sunset, you'll see a tiniest sliver the day after the new moon. And then the next day, you'll see a slightly bigger sliver, and the next day slightly bigger again, until a week later, you see a quarter moon. Another week later, you see a full moon. A week later, you see the final quarter of the moon, which is an actual half moon, and then it just keeps getting smaller and smaller until we get another new moon. In fact, it's probably going the other way, because, well, the moon lags behind the sun, so that is actually the way it goes. So the moon is actually going backwards in a sense, in so much as the phases appear to go backwards relative to the sun. So that is why after the new moon, you'll see the crescent moon just after sunset. And then the following evening, just after sunset, you'll see the crescent moon slightly higher in the sky. And then the next evening, higher again, and it's getting slightly fatter. It's waxing, as they say, waxing on. It's getting bigger. So the moon phases make perfect sense by looking from down below on the ground, looking up through the firmament B to see the actual tiny moon projecting direct sunlight into the firmament B. That's where we see light. Light does not exist above firmament B, it's all darkness. Apart from the bright orb of the sun itself, it is still visible in the firmament. So the phases, I think, also match our observations of what we see through the daytime. If we see a moon in the daytime, then the firmament B area, the sky, is actually fluorescing just like a massive open air light bulb, like a fluorescent bulb, but with the noble gas of argon dominating all of them. That's why the sky is blue. And so when you see the moon, it appears quite dim, and the parts that are not projecting sun energy into firmament B don't even appear to exist, because the fluorescing noble gases of daylight are so dominant that only the krypton being fluoresced or ionized by solar power coming as a reflection in line of sight to the viewer or observer to the moon creates the appearance or the apparition of the moon. And naturally it will appear to be the same size as the sun, because the sun is the source of the projection. But, well, the moon is actually the thing projecting it. So it wouldn't really matter what size the moon itself was, which is actually quite tiny. Now, if we look at high altitude balloon footage, I've got a few of those saved on my playlist. I highly recommend my favourite playlist is Heliocentrism Busted, and I've got a series of different videos that I get from all over the place, and it's actually an Eric Dubé one, which is quite a good one. I think it might have been re-uploaded by John Thor. So just look through them, probably done by John Thor, and it's basically showing once you get above firmament B into the black sky, the darkness of the edge of space, as they like to call it. If you do see the moon, you see a tiny, tiny little, yeah, you'd compare it the size of a ping pong ball compared to the size of a basketball size of the sun. And since I'm doing this video and I've only got limited amount of space, I'll just keep ranting and raving and explain then the solar eclipse. So that when the moon does cross the path of the sun in line with the viewer, so say this is the new moon here, so we can't see it, and then the sun of course is way up here and much bigger, but we only see the sun here in the firmament. So when the moon crosses it, it doesn't actually matter what size the moon itself is, or how near or far it is. It could be the size of a basketball, because as we all know, you can hold your thumb up to the sun and block the sun. So the size, in this case, doesn't matter. Complain to your wife later about that, if size matters. In this case, it doesn't matter. So the size of the moon could virtually be any old size, and I'm sort of in two minds about it, whether it is 70 miles wide or 30 miles wide or something in between. Generally speaking, something that casts a shadow cannot cast a shadow bigger than itself, or is it the other way around? It can't cast it smaller than itself. Like if we're making shadow puppets on the wall, I don't have a light source to be doing that at the moment, but often if you bring your hand closer to the torch that's creating the shadow puppet, then the shadow will appear much bigger on the wall. So if the moon casts a 70-mile shadow on the Earth during a solar eclipse, that doesn't necessarily mean that the moon is 70 miles big. It could be much, much smaller. It could be 7 miles big. That's one thing I don't know at this stage, and I'm not going to even give a wild speculative guess to. However, when it does eclipse the sun, obviously it's only to the people on the Earth below in the direct line of sight that see the sun being eclipsed, and it creates darkness around them locally. So it doesn't create night. All it does is it blocks the solar energy reaching the noble gases in firmament B to stop them from fluorescing, which makes it appear like nighttime locally, but there's enough surrounding light far enough away to stop it from being completely dark, so it sort of dulls the nighttime sky. So a lot of flat earthers will say that it can't be the moon blocking the sun. They're wrong. It can indeed be the moon. You just can't see it. And that's why it doesn't appear visible at any time during a new moon phase, because all of the solar energy of the moon is being reflected back to the sun at that time. So it's not being reflected or projected into firmament B to create the holographic plasma apparition of the moon that we have always thought of as the moon. It's not the moon. What we see down here is not the moon. It's a holographic projection, a hologram. The actual moon is a tiny thing way up here projecting that. And as with everything, it's subjective. It's a personal point of view. So people, let's say this was the radius of the Earth. So we've got Australia down here, we've got South America here, well, actually it's above the equator, isn't it? Africa's over here somewhere, all of Europe and whatnot. I'm really not a cartographer, so you'll have to forgive my crude drawing. But basically, what they're seeing from the sun being way above up here, shining onto the moon, which is here. So the sun itself, even though it may be way up here and circling around and spiraling up and down throughout the year to create the seasons, it doesn't actually create its orb of light until this firmament here. Anywhere on this firmament, This is the nature of light. You don't see it until it hits something. So this firmament is where the sun appears, even though it's up here. And so the moon, being roughly the same height, will then project that sunlight down here into firmament B in direct line of sight of the viewer. So we've got a viewer here looking, well, how can you draw up? Up is out here. You know, it's hard to draw a 3D diagram on a flat surface. You know, when people say Australians are looking south to see the Southern Cross, which is, you know, the Southern Cross, something like this, we're looking up at it. We're not facing south to see it, we're looking up, and we're seeing it around here somewhere. So when people here are looking up and seeing the Southern Cross, it's the same deal. It's just as it drifts around the sky in the same amount of time as the sun is drifting around. So when it's night time, they'll see the Southern Cross drifted around over here. They'll see it over here in South America, drifted around. Back here over New Zealand, seeing it drift around. We'll see it. We're facing south, but we're looking up. Up is this way. It's not that way. It's not outwards. It's this way. So the Southern Cross is still high above, just like the sun and the moon. You're just facing south. And so because Polaris is right over the middle, since we're having this quick discussion about the stars too as well, which I didn't intend to do, I was just here to talk about the moon. When you're looking towards the moon, towards Polaris, from anywhere on the stationary planar Earth, it's quite obvious, you know, because you can only see it to the equator, it's quite obvious that north is a different direction for every single viewer. So they're not looking the same way at all. They're looking a different way. We call it north. So when we're looking south, we call it south, but we're not looking the same direction at all. We're looking at a completely different one. So if you see all the stars going around Polaris clockwise, as you turn your back to see them going this way, now they're going from left to right, but when you're looking this way, they're going right to left. They're still going the same direction. It's the viewer who has changed direction. So the stars are not going the opposite direction in the southern hemisphere as they are from the northern hemisphere. They're going the same direction. The viewer has changed their point of view and is seeing them go a different way. And so that's pretty much the last argument that globers have, is why are they going. And now that enough say that we're seeing going around a fixed sigma octans. Now, I don't believe that for a second. I've never seen it. All I've ever seen, because I'm over here on the east coast of Australia, when I look out and see the Southern Cross, or look up and see the Southern Cross every night, by the time I see it in the morning, it's somewhere over here in the west, which is exactly where you'd expect it to be, because that's what the stars are doing. They're all going around above us. So by dawn, I can't see it at all. It's too far to the west. By which stage, people over in Western Australia, also looking up towards the dome, are seeing their version of the Southern Cross. And of course, the stars, just like the Southern Cross, are still above the firmament, but they still move as a single body. They just happen to move 4 minutes faster than the sun does, which is what we call a sidereal day. Now, the glober likes to think a sidereal day is the reason why the sun going around above us every single day is why we see it overhead at midday. They think that the clocks are somehow a magical device that we don't have to adjust by 4 minutes per day to keep the sun overhead. Whereas if we're on the spinning ball and we've got the sun in the center, and we're on the spinning ball going around the sun, then here is 12 o'clock. Here is 12 o'clock. Here is 12 o'clock. And here is 12 o'clock. So 12 o'clock here, the side facing the sun is 12 midnight. Here it's midday. It would change because we measure exactly 24 hours in a day with a physical clock. So therefore, the globes have no argument. However, if the sun goes around us once every 24 hours, then it won't matter how far away it gets for the 22nd of June solstice, our winter solstice, your summer, and how low it gets to the 22nd of December, again, our summer solstice, your winter solstice. It won't matter because it's still going to be in the same place relative to us, which keeps it overhead at midday every day without having to adjust the clock. The clock is the fixed timepiece that we measure the day by. And if we were doing it according to the heliocentric model, we would have to adjust the clock 4 minutes daily. So the sidereal day is basically the stars rotating as a singular body around us, and they move 4 minutes per day faster than the sun. The moon moves 50 minutes slower. That's what gives us the moon phases. And when it takes 365.25 rotations of the sun itself to go around us, by that stage the stars are back where they started, and that's how we know a year has passed. When the moon, being 50 minutes slower each day, catches back up with the sun again, that's how we know a month has passed. And because we divide the month into quarters, that's what gives us a week, because it's roughly 28 days in a month. It's actually 29.4, so that's why it doesn't quite add up, but that's nature for you. So moon phases work on the flat and stationary Earth. Thanks for watching, and I'll see you next time. Cheers.